Hello all, this is an introductory video to Java. So in this video what we will do is we will download Java and run a very basic program. Okay. Now we all know that Java is a platform independent language, right? It's not a platform dependent. Like there is a term called write once and run anywhere. So we will see why we call Java as a platform independent language. Okay. Yeah. So first I'll download Java. So let us go to Oracle's site to download Java. Yeah. So here you can search any version. Now the latest version is this, but you can search for any version whatever you want and you can download it. So I'm using Windows Mission, so I have selected here. Here you have OS specific downloads. So mine is a Windows Mission. So when I checked Windows, I have the zip files, MSI and the executable files. So what I'll do is I'll download it. Okay. Now before downloading, let's see whether Java is already installed or not and how to check whether it's already installed or not on our system. Okay. Now I'm going to the command line. Okay. Now here you have to type Java and then hyphen version. So if you type this, if a Java is already installed on your laptop, it will show. But here it is saying that it's not recognized. So Java is not installed on my system. Okay. Now I'm downloading it, right? So my download is completed. Let me install it. So this is I have downloaded Java 22. I'm installing the executable whatever I have downloaded. Okay. Yeah. So here you just click on next and this is the folder where my JDK or Java is getting installed. If you want to change the installation directory, you can do that. You can click on change and then you can change the installation directory. I don't want to change it, so I'm going with next. Okay. Now it is getting installed. Yeah. So here what you can do is if you want to, because there could be API documentation, the release notes, you can click next steps or I'm clicking on close. Okay. Now Java is installed on my system. Let me run Java version now to see if it is installed or not. Okay. So if you see, let me close it and open again. Okay. Now if I type Java version, you can see, right, it is showing that Java 22 version is installed on my laptop. Okay. Now what we will do is we will write a source code. So we all know, right, a source code is nothing but, because every programming language, it has its own syntax. Okay. Now if you like, let's say you want to print numbers from 1 to 10. If you just write print 1 to 10, Java can't accept that. It has its own syntax, so that if you want something to be done by Java, you have to follow the rules that are given by the Java, right? So every language has its own syntax in which you have to write the program. So that is called as a source code. First I'll write a source code for the Java. Okay. Now what I'll do is, I'm not using any editor, okay, like any IDE I'm not using, like Eclipse or IntelliJ. I'm using a plain notepad, okay. Now what happens is, in Java everything is classes. We will understand more about classes and objects in the upcoming videos, but let us assume that everything in Java is a class, okay. First what I will do is, I'll write a simple class file, okay. Now I'll write public class and I'm writing, this is my class name. Okay. Now if you see here, this is the public is the identifier, like access, because public, when you say public, this class is accessible by everyone. There are others as well, like private and protected. If it is a private, it is not accessed by anyone. So now my class is public because this class has to be accessed by everyone. And when this class is a keyword, these two are the keywords, okay, Java keywords. So when you mention class, then it says, it assumes that okay, this is a class file. Okay, and test main is the name of the class. Okay, public and class are the Java keywords, where public says that this class is whatever, be it a method or anything, this is accessed by everyone, and class is a keyword, and test main is the class method. Okay, now this is a class, and inside class what you will have is, you will have variables declared, on you will have methods as well. Now I am not going with any variables, I am just declaring my method. Okay, now what I am doing is, I am writing one more method which is accessed by everyone, since I am using the private, and I am using static keyword. We will learn more about the static keyword later. And then void. Void means return type. If this method returns something, then you, like let's say you want to return the name of your person, then the name of the person would be string. In that case you will give string. And if you want to return an array, you can give the array. Okay, but here I don't want to return anything, that's why I'm giving the void. Now main is the method name. So here what we are doing is, public says it is access, like to whom can act, whom this method or the class can access, who can access that. And static is the keyword which we will discuss later, and void is the return type, and main is the method name. Okay, now we can pass arguments to the methods, like we can pass any integer, or the string, anything. But here let me pass string of args. Okay, so here string of args is like, when you see this one, you can say this is an array. You are passing array of string. Okay, now what I am doing is, I just print name, like system. I want to print something to the console. So what I'll do is, I'll print, hi, this is an introductory video. Okay, what I'll do is, hi, this is an introduction to Java. Okay, this is an introductory video to Java. I'll write it. Okay, now this is what I have written. So this is the very simple program. Okay, now what we have done, we have created a class. Okay, and then we have created a method, and inside the method what we are doing is, we are printing something to console, and this can be anything. Now what I'll do is, I'll save this. Okay, like let me create a new project, and then I'll save it. Okay, so yeah, so what I'm doing is, I'm making a new directory, sample Java project. Okay, now inside this I'll create this Java file. So what I'll do is, I'll create this Java file inside the sample Java product. Okay, now I'll mention this as a test main. So here your class name is test main, right? So you should save your file with the class name. Okay, and the extension would be .java. So all Java source code files should be with the extension .java. So I have saved it. Okay, now how to run this program? I have written a program. Okay, I have written a class, and I have written a method, and how to run this program. Okay, so in Java what we have is, so here if you see in Java, first what we have done, we have written the source code. Okay, with .java extension. Now you have to pass this file, you have to give this file to the compiler, Java compiler. Okay, let me do that. What I'll do is, since I'm already in the simple Java project, and there is this test main.java, and I have to compile this program, and the command to compile the program is javac. So you have to use javac, and you have to give the class name test main.java. Okay, now it did not return any errors. Let us go back to the folder where this test main.java is present, and see what happened. Okay, now if you see here, so this is the simple sample Java project, and test main.java, this is the test main.java which we have created. Okay, now if you see, this is the .java file which we have created, and this class file we did not create it, right? So what had happened is, when you compile test main.java, what Java compiler does is, it will create a class file. Okay, with the same name test main, it will create a class file. If you say test main.class. Okay, now what had happened is, okay, like you have compiled it. People might think, okay, I have, like, it's just the compilation. It did not run the program. Okay, it just compiled the program. So if you see here, you're already printing, hi, this is an introductory video to Java. If this program was run, then you would have seen this particular string on your console, but you did not see that. So what had happened is, it did not run the program. It just compiled the program. Okay. So this is the step we have done here. So the source code, what we have done, we have given source code file to the Java compiler, and Java compiler, what it does is, it had generated a .class file. What is this .class file? Okay. So if you see this .class file will contain a bytecode. Okay. Let us open this. So you don't understand this, right? Somewhere you can see these strings and some Java.language, but this is not a human readable language. Okay. So what Java does is, whenever you write a program and then you give it to the compiler, it will generate a .class file which will have the bytecode. So the content in the .class file is the bytecode. Okay. This is the bytecode. Whatever we have seen here is the bytecode. So this bytecode, like this is a bytecode, and this bytecode is independent of the OS we are running. Now I am using Windows 10 64-bit mission, okay, but this bytecode, it's independent of mission whatever you are using, because few people would have generated this .class file on Linux or on other laptops as well, and even now I'm using Windows 10. Few other people would have been using Windows 7, or there could be different operating system that people are using. So whatever the bytecode that was generated now is independent of the OS that we are using. Now what we have to do is, this bytecode we have to pass it to the JVM. Okay, we are just following the steps whatever are mentioned here. Now to pass to the JVM, like to pass to the compiler, what we have done, we have used Java C command. Now to pass it to the JVM, we have to use Java. Okay, and now you have to run the class file. Okay, now what we can do is Java test main. Okay, now if you see, you can see, hi, this is an introductory video to Java. Okay, so what had happened is, when you gave bytecode to the JVM, it actually ran the program. Okay, whatever is the bytecode that you have given, it actually ran that bytecode. And since we had printed out, this is an introductory video to Java, you can see the same thing on your console. Okay, so if you understand how Java works, first you have to write a source code and then give it to the compiler. Compiler will generate a .class file, and .class file will be generated by the JVM. So now, as I said, bytecode, it's independent of the operating system that we use. But when you pass bytecode to the JVM, this JVM, whatever we have, it is specific to the operating system. Okay. Now let's say you have a bytecode, and then you want to, now I'm using Windows 10 operating system, right? Now you have to get a JVM specific to Windows 10. Then only it will run the bytecode. Okay. So what happens is, let us consider another languages like C# or the C. What they do is, they also will have the source code files, and whenever you interpret the language, directly they convert it to the low level language or mission code language. If you see, our OS accepts only zeros and ones, right? Binary zeros and ones. It doesn't know about this public, class, static, nothing. It doesn't know. What you have to do is, you have to give zeros and ones to the operating system, then only it will execute it. Operating system just know about the zeros and ones, machine level code. That is the low level code, right? It knows only about the zeros and ones. Okay. Now what happens is, usually when if you take the C language, what happens is, you have the C like source code which has the extension related to the C, and whenever you interpret the language, what it does is, it will convert this public class whatever we have into the zeros and ones, and then operating system executes it, and you will see this system.print, like this introductory video to Java directly here. Okay, directly it is converting the .java files to the machine level code, whatever the operating system we are using. Let's say if you are using Windows 10 or the Linux, directly the source code gets converted to the mission code, like operating system specific code, it gets converted. But in Java, what happens is there is an intermediary step called this compilation and the bytecode. First, it will convert it. It gets converted to the bytecode, and this bytecode is independent of the operating system. Okay. Now, whenever you generate bytecode, you can send this bytecode to anyone. Like you can send this bytecode to the Linux system, you can send it bytecode to the Unix system, anything. And those Unix and Linux systems, they will have their OS specific JVMs and they can execute this bytecode. That's why Java is called as a platform independent language, because whatever the bytecode that got generated here in this intermediary step is independent of the operating system that people are using. And when you ship this bytecode to any operating system, they should have, like, this bytecode will be executed only by the JVM. So they should have the JVMs installed on their machines. Like, so you can see that Java programs are present on the mobiles or watches everywhere, right? So let's say I have written some program related to the mobiles or watches and I have converted it to the bytecode and I send it to my mobile or my watches. So what those gadgets will do is they will have their inbuilt JVM and they will execute the bytecode, and you can see something running on your mobile or the watches. Okay. So because of this bytecode, Java is called as a platform independent language. So Java compiler is a platform independent, whereas JVM is a platform dependent, because when you are converting the bytecode to the mission code, you have to convert it to the OS specific, right? Bytecode, you need not convert it to the OS specific, but this bytecode has to be converted to the OS specific. That's why JVM should be OS specific. Okay. So what happens? First, you write a program called .java and then you give it to the compiler. Compiler will run .class file and you will have your bytecode generated and give that class file to OS specific JVM. So you might ask, when did you download this JVM? So I have downloaded this JDK, right? JDK will have a compiler and then the JVM inbuilt in that. So I did not download it specifically. JDK itself has, JDK stands for Java Development Kit. So Kit has all these inbuilt. That's why I did not download specific Java compiler or the JVM. Okay. Now what compiler does? So like people might say, why you need the compiler in between when JVM is the one which actually executes the program, because when you run Java test main class file, then only you can see that. So here compiler does lot many things. Now let's say if I do this, now this is the proper syntactic program, because you have a open brace and you have a closed brace here. Let's say I did this, like I have removed the brace here. Okay. Now let me save and let me run it again. Okay. Java C test main.java. Here if you see, it is saying that it is Java 2, it is expected, like semicolon is expected, because in Java sentences ends with semicolon, right? Here you did not give any open brace. It thinks that it is one more statement and it should end with this. Okay. So if you see, Java compiler does all syntactical checks. Okay. Now let's say here if you see, it is saying that this one is expected. Let me do one more thing. Okay. Now I'll not use this class. Okay. I'll not use this class. Now let me run it again. Java C. So if you see error, test main.java, first line itself you have the error, class interface enum or record expected. Okay. And the second line also it is saying that you have 3 errors here. Okay. Now because you did not specify this class here, if I specify class, then it will work fine. Okay. Now if you see, now let me clear it. Now it did not return any error. So what compiler does is, when it is converting to the bytecode, it doesn't convert bytecode, it doesn't convert blindly to the bytecode. It does all syntactical checks. Okay. Now if the compiler doesn't do all these syntactical checks and it directly converts it to the bytecode, then it will be an overhead to the JVM, because JVM has to do these syntactical checks and everything, right? but compiler takes care of all those. It does all syntactical checks and whether it's following the proper instructions or not. Let's say this system, like here if you see system.println, this is a proper syntactical program because you have used semicolons, you have used open and close braces, everything. But this println method is not present on system class. It is present on system.out. If I run, it will throw error because it says this particular println method is not present in the system class. Let me do this. So if you see, it is saying that cannot find symbol because println method is not present. So along with the syntactical checks and all, it checks whether these methods are present properly or not. Okay. So all these things will be taken care by the compiler so that it will be not an overhead to the JVM. It just not blindly converts it to the bytecode. It does the syntactical checks and then it will see whether all methods are present or not. It does all these extra things and then it converts it to the bytecode so that it will not be an overhead to the JVM. Okay. So now we understood why we call Java as a platform independent, right? Because of this intermediary step we call bytecode, and this bytecode can be executed on any machine. That's why we call Java as a platform independent language. Okay. In the coming videos, we will learn about Java in detail.